Hi guys, this is quiz number 2, practice. Um, so, for each of the following, use the right triangle below. So basically, when they give you a triangle like this on the test, go ahead and draw another one just like it for the second one. I only gave you one, so just make sure you know that you have to do this for the second one. So we'll use this one for the first one, this one for the second one. All right, these are all SOHCAHTOA. The whole first page is going to be from SOHCAHTOA. So just write that down. All right, if B equals 72 and C equals 5.8, find B. So if B is 72 and C is 5.8, find little b. So circle what you were given and circle what you're finding. And then you have to ask yourself, what is given from 72? What is b? B is the opposite side. And what is 5.8? It's the hypotenuse. So which one of those of the SOHCAHTOA would you use? You would say sine. So you go sine 72 equals opposite, which is, what is that, b? B over hypotenuse, 5.8, and you just cross multiply. So you go sine 72 times 5.8, 5.5. And that's b. So b is 5.5. Number 2, little a, that's across from angle A, is 24. It goes down here. Little c is the hypotenuse that goes here. And they want you to find angle B. So according to angle B, this is the adjacent side, and this is the hypotenuse. So that means we want to use cosine of angle B. And that is adjacent over hypotenuse. So to solve for an angle, you want to inverse cosine both sides. Whenever you're solving for an angle, that's what you're going to have to do. And you're going to punch that in your calculator. So second cosine, 24 divided by 30, 36.9. Oops, can you guys see that? 36.9 degrees. So angle B is 36.9 degrees. This next one is you have a jet that's going to plan its descent to Ronald Reagan Airport. It's 3,900 feet from the ground, so people can see it. And its angle of descent is 6. Now, the angle of descent is on the outside of a triangle. It's right here, on the outside. But angle of depression and angle of elevation are the same place. So using alternate interior angles, that 6 is going to come on the inside. We're going to place it right there. So basically, if I redrew this, this is 6 degrees. This is 3,900. And the first question is, what is the plane's ground distance? Ground distance is the bottom part, so that's right there. So according to this, we've got 6 degrees, we've got an opposite side, and we've got an adjacent side. So this is tangent. Tan 6 equals opposite, 3,900, over adjacent x. So this is what happens when you have an x in the bottom. It's kind of hard to cross. I mean, you could cross multiply, do a couple steps, but all you have to do is switch places with these two. So the x equals 3,900 divided by tan 6. So we're going to punch that in the calculator. 3,900 divided by tan 6. So the ground distance is 37,106 feet. For word problems, make sure you always put the units in, so that would be feet. Same problem, how far must a plane fly to reach the runway? So it's the same problem, but we're trying to find the hypotenuse. So we still have the 6 degrees, we still have 3,900, and now they want us to find the hypotenuse up here. So that means we would be using sine 6 equals 3,900 over x. That's the same problem as the last one, except that when we switch places, it's going to be 3,900 divided by sine 6. Last time it was divided by tan 6. So it's pretty much the same work. Actually, because it's the same work, I'm just going to press second enter and go backwards and change tan to sine, because everything else is the same. And I'm going to get 37,310 feet, 0.4. And there's your answer. That's how far the plane must reach to the runway. So an 8-meter ladder leans against the building. So you have a building, right? Building. And a ladder is leaning up against it, and it's 8 meters long. Because it says it's 8 meters long. If the ladder makes a 60-degree angle with the ground, this is your picture, 90-degree angle. Question number 1, how far up the wall does the ladder reach? How far up the wall, that's this, does the ladder reach? So this is the opposite side, and this is the hypotenuse. So you're going to say sine of 60 is opposite x over hypotenuse 8. So we're just going to cross multiply. And get 6.93 meters. How far from the wall is the base of the ladder? So it's the same picture, right? We got 8, 60. This is our 90-degree angle. This time they want to know how far from the wall, so that's this one right here. How far from the wall are you? So this would be cosine of 60 is adjacent x over 8. So it is cosine 60. Oops, I meant to say times. Whoops, let's go back. Times 8. Cosine 60 times 8. And that's 4 meters, and you're done with the first page. Page 2. Solve each problem. All right, so we're going to have to draw these. Okay, see, these are not right triangles, so just draw general triangles. Label them A, B, and C. We'll do that for the next one too. Might as well get it ready, right? A, B, C. So for the first one, angle B is 49 degrees, angle C is 32 degrees, and side A, which is across from angle A, is 10. This is angle, side angle. Anytime you're given two angles, you're going to use law of sines. Law of sines is the proportion. So before I start, I always want to find my third angle. So we're going to go 180 minus 49 minus 32. And that is 99. Do you guys see that? I did 180 minus the other two angles. I got 99. And law of sines. The only one that we know both parts to are the A's. So side A over sine of angle A. That one is one of your ratios. And they're asking us to find B, just the B. So I'm going to put the B in here, and we're going to use this ratio. So this is little b over sine of the big B, 49 degrees. From here, you're going to cross multiply. You're going to write 10 sine 49. And you're always going to divide by the one across from little b. This one right here. You just punch in your calculator, and all this equals b. So you have 10. Let me clear all this stuff out. So you have 10 times sine 49 divided by sine 99. .64. And that is B. Okay, next one. Angle B is 48. Little a is 14. And side C is 18. Now this one is SAS. So if you know two sides, you want to use law of cosines. Okay, so law of cosines, little b, is side number 1 plus side number 2 minus 2 times side times cosine of 48 degrees. This is, to me, the easiest one because it's just straight calculator. Don't forget to press second square root first. See that little square root? Oops, can you see it? Make sure you have the square root in there first. Now we're going to do side squared plus side squared minus 2 times the first side times the second side times cosine of the angle, which was 48. So it looks like this. When you punch in the calculator, oops, there it goes. You press enter. And we were solving for a side, and that is 13.5. Side B. An Earth orbiting satellite is passing between the Oak Ridge Laboratory in Tennessee and the Langley Research Center in Virginia, which are 446 miles apart. You guys see that number right there? 446. It's right there on the bottom. If the angles of elevation to the satellite from Oak Ridge is 58, right there, and 72, respectively, how far is the satellite from each station? I changed this to just tell me from Oak Ridge. So just from Oak Ridge. So we want to find this one right here. This one here. It's kind of dark. So if I redrew this, I'm trying to find this. I need this, probably this, and this. I'm trying to find this one right here. So what should we do? We are given two angles, so we're going to be using law of sines. But I like to find the third angle, and usually we do need the third angle. So let's find the third angle. 180 minus 58 minus 72. So the third angle is 50 degrees. So which ratio do I know? I know this ratio. So you're going to start with 446 on the top, because that's the side, over sine 50. And we're solving for b, so we're going to go b over the one that's opposite that, which is 72. Cross multiply, 446 times sine 72 divided by sine 50. All this equals b. $553.7. So 553.7. And this was in miles. So make sure you have miles in there because it's a word problem. And that's how many miles you are apart from Oak Ridge. That's the satellite. Now the satellite, you got to remember, the satellite's in the air, so that is supposed to be far. Satellite's in the air, and you're going from Oak Ridge. All right. Next question. A hockey player attempts a shot. He is 22 feet from the left post. 22 feet from the left post, and he's 25 feet from the right post, as shown. And the goal is 6 feet apart. So they want us to find this angle. So this is sides. Whenever you get no sides, it's going to be law of cosines. But it's the other law of cosines. I have these formulas on the back. Let's look. So there's law of cosines that look like this when you're trying to find a side. And then there's law of cosines. These are the same formulas as these, but I just manipulated them when you're trying to find an angle. So just kind of pick one of these. It doesn't matter. But it's going to look something like this, where you have a side squared plus side squared minus another side squared over 2 side. The one that you subtract is across from the one you're solving for. Just remember that. The one that you subtract is across from the one you're solving for. So let's go back to this. So since I'm solving for this angle, this is the one I'm subtracting. So let's set that up. Cosine of theta. Solve cosine. The one that you're subtracting is across from the one you're solving for. So then the other two go here and here, and here and here. And then this is 2 times 22 times 25. So we're going to when you put these in the calculator, don't forget your parentheses. So it looks like that. You guys have your parentheses, press equals. Now that's not your answer. That's what cosine theta equals. So it's like this. So in order to get theta by itself, you're going to do inverse cosine, both sides. So you're going to press second cosine. I'm going to go up and highlight this. See, I highlighted it. Bring it down, and then press enter. 12.7 degrees. So your shot has to be about a 12.7 degree angle. It's going to hit the goal, so 12.7 degrees. Whoops, there it is. Okay. The back page is all areas. Find the area of the quadrilateral. Now, this is one just like this on the test. You want to start with triangle 1 and triangle 2, and at the end you're going to add triangle 1 and triangle 2 to get your total area. Okay, so you're going to do triangle 1 plus triangle 2. So let's start with triangle 1. To find the area, you are given SAS. Now these are on the back. So an area for SAS is this one. SAS, you see that? It's 1/2 side, sine of the angle. 1/2 side, sine of the angle. So, where's that at? So it is 1/2. Now we're looking at, I'm going to cover these up. Looking at triangle 1 here. So side, angle, side. So it's side times sine of the angle. So area number 1 is, I always put 0.5 in for 1/2 times 9 times 11 times sine of 70. So you get 46.5 units squared. So that's your first area, 46.5 units squared. But that's not your final answer because there's a second triangle. So now we're going to do triangle 2. Now this one's different. This one's got 2 angles. So your angle formulas, if you remember, right? Let's go ahead and find the third angle first. And whenever you have 2 angles, you have to find the third. We're going to do minus 60 minus 58. So the third angle is 62. Okay. It goes right here. Okay, now that we know, basically you know all 3 angles and a side. So the formula on the back is going to say 1/2. The side squared. That's 13 squared. And then you always divide by sine of the angle across from 13, which is 62. That one goes on the bottom. And then the other 2 angles go on the top. So 60 and 58 go on the top. So that's what this problem looks like. So just if you're wondering what I'm doing, these are on the back. If you're given angles like this one, you do 1/2 the side squared, sine, but the angle, do you see this? The angle that you divide by is the angle across from the side that you're given. So that's the formula. That's where I got the formula. So we are about to put this in the calculator. So we're going to go 0.5 times the side squared times, I go across the top. So we're going to go sine 60 times sine of 58. You see I put all this stuff in the top. Press equals. And then press divided by the sine of the one on the bottom, which is 62. For 70.3. Now that's not your final answer. So now you're going to take 70.3 and add it to 46.5. For a total of 116.8. That's your total area. Farmer Fred needs to form a pen of new piglets. He has 3 sections of fence he plans to use. If the lengths of the sections are 20, 16, and 8, find the area of the enclosed pen. So this formula is the S minus A, S minus B, S minus C formula. So the first thing we have to do is find S. S is 1/2 20 times 16. Oops, I'm doing that wrong. It's the half of the perimeter. So it's 20 plus 16 plus 8. So this is 24 and this is 44. So this is 22. And number 2 is 22 times 22 minus 20 times 22 minus 16 times 22 minus 8. You're going to punch this all in the calculator. So this is 22 times 2 times 6 times, what is that, 14. You punch this all in your calculator. You can punch the big long one in or the long one or the one where you already did some subtraction. 2 times 6 times 14. 60.8. And that's your area. And make sure it says feet squared. And the back. You can use the unit circle. This is what you guys did unit circle last year. But you don't actually have to use the unit circle, or you could. All you have to do is do arc sine of radical 3 over 2. See this? To get rid of sine, you just do sine inverse both sides. So if you did second sine of square root of 3 close your parenthesis. No, you don't have to actually. Go out of that though. Divided by 2. Then do your parenthesis. You're going to get the answer, 60. Now let's look at the unit circle just for a second. Let's look at 60. Here's 60 degrees. The sine is the second one. It's radical 3/2. So if you know that cosine is the first, is the x-coordinate, and sine is the second one, you could just find, when it says find where sine is radical 3/2, you can find it right there. Sine is radical 3/2 at 60. You wouldn't need the calculator, but we have a calculator, so we might as well use it. And then find this one, arctan of -1. So if you did arctan of -1, ooh, you get -45. Now, I'd accept this answer. I'd accept that answer, but do you know that -45 is the same thing as, here's -45. It's the same thing as 315. So you could use 315 as well. So tan -1 is at -45, or you can say 315. Accept either answer. On this one, do arc cosine of 0. And it's 90 degrees. So write 90 degrees. Let's look at 90 degrees. Look at 90 degrees. Here it is. Notice that the cosine, which is the x-coordinate, is 0. So when is sine -1? Do arc sine of -1. It says -90. Oops, you see it? -90. Or if you look at this, if you go backwards, -90, it's also 270. So you can say also 270. Notice the sign right there is -1. And this one, do arc cosine of negative radical 3/2. So do second cosine of negative square root of 3, right arrow, divided by 2, for 150. And what's the arc sine of negative radical 2/2? -45. We already had a -45 earlier, so we could also say 315. And there's all your formulas that you're going to need. They're on the back. You can use these at any time. And we're done.